Because the metric system is based on our number system itself, converting within the metric system is really pretty easy as long as you have this chart handy, which you actually do. It is in your formula packets on the back of page 2. So what is converting all about? Well, sometimes the units you have are not the units that you need. For example, we're in the process of finishing our basement, and my carpenter told me what the square footage was. When I called out the carpet person to come out and give me an estimate for the floor, he gave me a price in square yards. So the units I had, which were square feet, were not the units I needed, which were square yards. Rather than going back and remeasuring things, it's easier just to convert the units you have. So we're going to talk about first converting within the metric system. Because the metric system is streamlined and based on our base 10 number system, converting is pretty easy. So let me show you how it goes, and then we'll take a look at why it works. Let's start with this first one, 5 kilograms, and we want to go to grams. So all we need to do is locate where we are at on the chart. In other words, we're starting at kilograms. Kilo is here, and we want to go to grams. So we're going to see how many steps and in what direction we need to go. So that's 1, 2, 3 steps to the right. And all we will simply do is take our decimal point and do the same exact movement. In other words, 1, 2, 3 steps to the right. We fill in with zeros and we get our converted answer. So going from kilo to grams was 3 steps to the right because grams is one of our base units. So we took our decimal point and went 3 steps to the right. If we look at the next one, we are starting at centimeters and going to just meters. So when you see just the single letter, as we see here, that indicates there is no prefix. It is just the base unit by itself. So we locate centi on the chart. Remember, meter is one of your base units. To go from centi to meter, it's 1, 2 steps to the left. So when we don't see the decimal point, it's at the end of the number. We will take and move our decimal point 2 steps to the left, just like the chart. You can put the 0 on the end if you like, but you don't need to. I'd like you to take a minute, pause the video please, and please convert this one, 1,432 millimeters to meters, and 12.2 liters to deciliters. All right, so hopefully you took a minute and you did these on your own. We're going to go over these two now. For the 1,432 millimeters, milli is here, and to go to meter, which is a base unit, that's 1, 2, 3 steps to the left. So we'll take our decimal point and go 1, 2, 3 steps to the left. So we get 1.432 meters. To go from liters, as we're looking to in this case, to deciliter, remember liter is your other base unit. To go from liter to deci, that is 1 step to the right. So we will simply take our decimal point and move 1 step to the right. So we get 122 deciliters. Now, why is it that this works? Well, consider, if you take a number like 5.3 and multiply by 10, you can go ahead and do it on your calculator, and what you'll get is 53. If you take that same number and multiply by 100, what you get is 530. One more time, we'll take 5.3, but this time we'll multiply by 1,000. That's 5,300. Take a look at what's happening to the decimal point in each case. When we multiplied by 10, it moved 1 step to the right. When we multiply by 100, 2 steps to the right. Multiplying by 1,000, it actually moved 3 steps to the right. So every time we multiply by 10, that's pushing our decimal point to the right. Furthermore, for every factor of 10, that's how many times the decimal point moves. In other words, sometimes we remember the rule for every 0. That's how many steps we'll go. That's because there's 2 factors of 10. 100 is 10 times 10. So that's why we move the decimal point 2 places to the right here. 1,000 is 3 factors of 10, and it went 3 steps to the right. Okay. If we look at dividing by 10, if I take 5.3 and divide by 10, I get 0.53. 5.3 divided by 100, gives me 0.053, and 5.3 divided by 1,000 gives me 0.0053. Here we see when we divide by 10, the decimal is moving a step to the left for every factor of 10. Well, consider what was happening when we were converting, say, kilos to grams. Now, I know that there are 1,000 grams in a kilogram, but for me, the issue is remembering whether I'm supposed to multiply or divide. The chart takes out the guesswork. For every kilogram, there are 1,000 grams. So I would take and multiply my 5 kilograms by 1,000. In other words, that's going to push my decimal point 3 steps to the right. Look at the chart. From kilo to our base unit of a gram, 1, 2, 3 steps to the right. So the chart has that movement embedded. As long as you have the chart set up in this order, it's sort of already set up to show you whether you're multiplying or dividing by moving left or right, and how many factors of 10 or how many times you have to move that decimal point. Now, in all the above examples that we just did, we were converting what we call linear units. In other words, all the units had an exponent of 1. But look at the bottom 4 examples. In this example, we have an exponent of 2. So sometimes we're converting square units to another square unit. We may even be converting cubic units to other cubic units. Fortunately, in the metric system, this process is not much harder than what we've already done. So let me just clean this up really quick so we have a nice clean chart to work from. And then we'll take a look at doing the square conversion. If we have 135 meters squared and we want to go to kilometers squared, here's the thing. At first, we're going to do just what we would do if it was a linear conversion. In other words, just go from meter to kilometer. So that's 1, 2, 3 steps to the left. We completely ignore the exponent at first. However, the fact is the exponent is there. So we do need to account for it. And what that exponent tells us is whatever we would do on the chart, when we apply the exponent, which in this case is a 2, we're going to double it. So if the linear conversion from meter to kilometer was 1, 2, 3 steps to the left, for a square conversion, we double it to 1, 2, 3, 4, 5, 6 steps to the left. So that gives us 4 zeros. I believe 1, 2, 3, 4, 5, 6. Oh, my mistake. That's actually too many zeros. So let's take a quick look at that example one more time. I'll write it a little bigger. So again, meter to kilo is 1, 2, 3 steps left. The square tells us to double it. So 6. 1, 2, 3, 4, 5, 6. I'm going to insert zeros into the missing places. So I have 3 zeros followed by the 135. Now for the linear conversions up here, we did what the chart told us. For the square conversions, we doubled. If you're thinking for a cubic conversion, we're going to triple, you are right on. So let's take a look at this next one. We start with 4.2 meters. We're being, or meters cubed, and we're being asked to go to cubic centimeters. At first, let's just ignore the exponent. Meter to centimeter, that's base unit to centi, 1, 2 steps to the right. The cubic is going to tell us to triple that. So 2 steps on the chart tripled is 6. 1, 2, 3, 4, 5, 6. Put the zeros into the missing places and write the decimal in the new place. So in other words, that's 42 with 5 zeros. So 4,200,000 cubic centimeters. Okay. I would like you to pause the video again and please take a minute to do the next 2 examples. All right, welcome back. We are going to take a look at what the answers to these 2 should be. You may have found the second one a little bit obnoxious. It was quite a large one to do. But let's go ahead and start with the 57 square centimeters. So if we were looking at just centimeters to millimeters, that's one step to the right. But the square is going to tell us to double that to 2 steps to the right. Putting in the zeros gives us 5,700. This next one, 2, 3, 4, 6, 4. DG is decigram, that's cubic decigrams, and we're going to cubic kilograms. So from deci to kilo, if it was a linear one, a linear conversion, deci to kilo is 1, 2, 3, 4 steps to the left. Because it is cubic, we're going to triple that to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a very, very, very small number. I don't think at any point in your life you would ever have the need to go through and convert cubic decigrams to cubic kilograms, but it does make for a good example. So I promise on the exams I will not give you one this obnoxious. So there you go. You should have 7 zeros right after that decimal point followed by your number. Okay. In the next video, we're going to talk about converting within the U.S. customary system as well as converting across systems.